All right, we're going to do an example. Conservation of momentum in two dimensions. Right? X and Y. The premise of the problem is fairly simple, right? We have ball number one. Mass number one is 1.20 kilograms. And it's at a trajectory of 30 degrees below the horizontal, which in proper direction would be what? Does anybody know?
330.
330, right? Proper direction is 330 degrees of ball number one. Ball number two, and it's traveling at a speed of 10.0 meters per second.
It looks like it's an N.
Yeah.
No, it's an M. From my perspective, I made a second thing. You just can't see it because it's very small. Number two, ball number two is down below ball number one. It is headed upward at a proper direction of 40 degrees. And it's traveling at a speed of 15.0 meters per second. Ball number two is much more massive than ball number one. It has a mass of 2.31 kilograms. These two objects collide and bounce off of one another in an elastic collision. Ball number one continues on forward with a new velocity above the horizontal on an angle of 25 degrees of 13.5 meters per second. And the question is, what is V2 prime? What is the new velocity of ball number two? Anybody have any questions on the premise of the problem? Fantastic. All right, so what we are relying on is a two-dimensional frame of reference where I'm going to say up is positive y and to the right is positive x. We know that momentum of the system is conservative. P equals P prime. But moreover, P is a vector that is comprised of two directions, which means that the overall system's momentum can be split into two independent directions where we have the momentum in the x direction of the system as a vector added to the momentum of the system as a vector in both the x and the y direction. This can then be divided up on this side as px prime plus py prime. Total momentum of the system is conservative across all domains. Since x and y are independent, what we're actually going to do is basically take just these two and do just x, and then just these two and do just y, right? And that allows us to determine the information necessary to work backwards to find this. Sharp.
But py isn't equal to py prime necessarily, is it?
Absolutely.
Oh.
Absolutely. The independent directions must be conserved. So py is absolutely equal to py prime. Absolutely. Any other questions?
You can't say like px equals py prime.
Correct.
Be great.
Because x and y are independent of one another, you cannot say that. Very good. Any other thoughts? Okay, so first thing we're going to do, I'm going to erase this so I have some room to work. In order to do conservation of these objects, I first need to know what the momentums are, because the momentums are not given. Right? In the radioactive nucleus problem I showed you, they were already calculated as momentum, right? But this is given as velocity, which means that this diagram is ultimately not that useful until it's in terms of P, right? So P is mv, which means mass times velocity is the momentum of ball number one. Now the direction of ball number one is determined by the direction of the velocity, so the arrow that represents momentum over here looks pretty much the same, except that it's much longer. Because I literally took 1.2 and multiplied by 10.0. Make sense? And so this would be P1. P1 can be calculated by M1 times V1, which will be 1.20 times 10.0, which is 12. kilogram meters per second. This angle is still 30 degrees. And then in planning ahead, this angle is 30 degrees because they are alternate interiors based on the two parallel horizontals.
We love math.
I love that.
We love math. Very good.
All of our hearts.
Everybody okay with that?
Yes.
All right, so then down here, ball number 2 is traveling up on a steeper slope and is moving much faster. Means that overall the vector is probably much bigger.
That's
Well, I can't draw it.
The angle offset, I didn't draw that in very straight
I draw it.
line. Draw it a little bit better like that.
That's just not what I do.
Where this angle is 40 degrees. This is P2. P2 is M2 times V2, which in this case is 2.31 times 15.0, which is
34.65.
34.7 kilogram meters per second.
Right. So is that angle below
Yes?
30, 42?
Absolutely. So there is an angle here that is also 40 degrees.
Which way does that little arrow go?
This, like this.
Oh, I drew it right.
Not that it really matters, but yes,
It doesn't.
not particularly. Yes.
Yeah, I understand the math portion of it, I just don't understand the English. Why that could have been.
The angles are the direction that the balls are traveling, right? So ball number 1 is coming down and to the right. Ball number 2 is coming up and to the right, which is why they're going to collide. P is MV. The direction of the velocity determines the direction of the momentum, because mass is what we call a scalar. It has no unit, it has no direction, it only has unit, because mass is just a measurement of how big the objects are, right? So the momentum of ball number 2 is the inertia in motion, right? And the inertia is the mass, and the motion is this direction, which means the momentum is in this direction. And so the angles literally just transpose over.
Okay, so we don't have to do any
Not yet, but now we do. Because in order to analyze the two independent directions, we need to first resolve the givens into independent directions of x and y. That's what the angle is for, is to find those values. So I'm going to use new colors in order to isolate x and y. The best way I have found to do this is to do it verbally, right? And so this arrow points down and to the right. And so it points down and to the right. These are perpendicular to one another. This one points in the vertical direction, which means that this is P1y. This one points in the horizontal direction, which means that it's P1x. This is also the reason why I went ahead and labeled that angle, so that I had an internal angle, so that I can use the geometry to find P1y and P1x. Come back to that in just a second. This vector points up and to the right, and so up and to the right looks like that.
Could you have also done?
You could also do to the right and up. Either one of those is absolutely fine. That makes this top one P2x, and that makes this one P2y. P. Did you say prime? No. No primes yet. Remember that this is just the beginning,
Oh, great. That's really
right? Not the end.
So we're just trying to find the velocity, like V2 prime, right?
Correct.
Didn't you just plug it in for the equals what did you get? Didn't you just plug in everything?
No,
Because they're not in the same direction.
they're not in the same direction. They are not parallel. It only works if they are linear and I can call one direction positive and one direction negative. But since this is not even close to something similar to this, I have to first separate them into x and y. Make sense? Okay, so what we just did there is P, the system's momentum beforehand. But according to the problem, we also have information afterwards, right? And so we're not done with our initial setup here. Because after the collision, ball number 1 goes on this lower angle of 25 degrees, where this is P1 prime, which is equal to M1 times V1 prime, which in this case, M1 is still 1.20, but V1 prime is now 13.5. Which means that
Where'd you get 13.5?
here. Right, remember that we're doing P equals P prime, so we need to know as much of this in terms of momentum as possible. So I have that as 16.2 kilogram meters per second. Mass times velocity.
Oh, yes.
I know, I'm not judging you, I just said it out loud. So again, this does not point in the positive or negative directions, which means that we need to resolve that into perpendicular components. It points to the right and up, or up and to the right. I'm going to do up and to the right since I put most of my writing on the right-hand side. Again, I know that this angle is 25 again, for alternate interior reasons. This is P1y prime. This is P1x prime.
Okay, so we go.
Yeah, it would still be going to the right and then up. And those would still be corresponding things with the terms that I'm going to write down in terms of math. So what we've just done is we've left it as a possibility for us to determine P, sorry, my purple's dying, P2y prime and P2x prime. We're going to find these two values and then build a new triangle to find the solution, right?
Yes.
Yes.
I agree.
Take them apart
I got that.
and then put them back together. That's the overall problem.
Would it be a problem if I got P2x in the second triangle to be, P2x in the second triangle to be bigger than P2y? Is that a problem?
No.
Because, well, your drawing just makes it look like that one's smaller, but that doesn't matter, right?
Right, as long as you're using the geometry, it should work out fine. Okay, so then we need to do all the necessary math. So I'm going to go ahead and erase this premise, right? Because this is all velocity information that's not useful for solving the momentum, right? So I'm just going to erase this setup that I had at the beginning. All right, so if we take let's do x first, right? We say that the momentum in the x direction is conserved through the system, right? So P1x plus P2x equals P1x prime plus Px prime. What's so fun? Oh, okay, so, right?
Does not know if.
P1x plus P2x equals P1x prime plus P2x prime.
Great. Okay, sorry.
P1x is this. So either here in the math or over there on the triangle, whichever you're more comfortable with. P1x is P1 times the cosine of 30.
Yeah, P1x
Good.
is
So let's make sure everybody's clear on how I got that, because I saw some wrinkles.
10.4.
If I set it up originally, Leighton, right, I would say the cosine of the angle is equal to the adjacent P1x over the hypotenuse P1. And so what happens is that the components are always the hypotenuse times whatever trig function is related, which is how I'm jumping straight to that result.
Oh, sorry, yeah,
Does
thank
that
you.
make sense? So P1x is P1 times the cosine of theta 1, which is 30 degrees. Right? P1x, or P1, we know is 12.
So you just do.
So then-
God, Georgia.
It is 10.
Yeah, I got
Right.
10.4.
All right, so what do you got, 10.4?
Yeah.
Yeah.
This is 10.4. So then that's plus P2x, P2x,
26.6.
Leighton, P2x is also adjacent to the 40 now. And so I know adjacent, so SOHCAHTOA goes with the cosine function. So again, hypotenuse times this gives me the piece. So P2x is P2 times the cosine of 40. Make sense? Perfect. And on this side, I actually can calculate P1x prime because I have all that information from that triangle, right? Because I have the angle and I have the magnitude of the
I
hypotenuse.
got,
So again, this is P1 prime times the cosine of 25.
I got 12.2.
And then it's plus P2x prime because that's an unknown.
It can't be bigger than.
So I have 10.4 plus,
Oh, 15.
what was this one? P2?
P2.
P2 is 26.6.
26.6, good.
No, you did it right.
And P1 prime, x?
14.7.
14.7, very good.
Glenn, stop.
Plus P2x prime.
This one.
X or Y.
Now, the only thing I want to double check at this point, right, is that they're all in the same direction. Right? I'm double checking to make sure. This points to the right, so it should be positive. This points to the right, so it should be positive. This points to the right, so it should be positive. Don't be thrown. It's very possible in bowling that the ball will end up going backwards, so these numbers could be negative. They're just not in this example.
Yeah, I got 14.
All right, so then I do 10 plus this, minus 14.7, and I get P2x prime equal to what?
22.3.
22.3 kilogram meters per second.
Aren't you not done?
And I'm not done.
You have to do Y direction.
Right, so 22.3 kilogram meters per second is P2x prime. So I filled in one of the two.
Oh, and then you use your triangle to find the hypotenuse. Now you're like P2 Y prime.
Yep, so now we're going to do P2y prime. So I'm going to erase this.
And do the triangle first.
Well, we already did the triangles.
Oh, is it just?
So now I'm going to write basically the exact same statement, only in the y domain. So now I'm going to say Py is equal to Py prime, which means that P1y plus P2y equals P1y prime plus P2y prime. 2. Oh. P2y prime is what we're trying to find. That's the goal at this point. And everything else we know because we've set up the trig so that we can solve them out. Now again, you could totally do the sides of the triangle prior to getting to this step if you're more comfortable doing the trig functions off to the side. There's nothing wrong with that, right? But I've gotten fast enough now that I'm confident this is opposite, and so it's the hypotenuse times the sine. And then just to double check, they're all hypotenuse times the sine. So just like the last ones were all cosine, these ones are all sine. Now that's just because this setup worked out that way. It is not always that x is cosine and sine is y, not always. All right, so py prime, or py, right, is 12 times the sine of 30. P2y is 34.7 times the sine of 40. Equal to P1y prime, which is 16.2 times the sine of 25, plus P2y prime. Run all of these numbers.
What did you get?
P1y,
6.
6,
But isn't it gonna be -6?
but it's going to be negative 6.
Wait, how did you know that?
Because
Some
it's
pages
going down.
Going down.
How do you know that?
Very good.
Okay, so it's direction.
So then the next one is also down.
No.
Oh, I did the
Because the next one, no, the next one's up. So plus, next one's up, so plus 34 times the sine of 40 is what?
22.3.
22.3 equal to
6.8.
6.8. Is this positive or negative? Positive, it's going up, plus P2y prime.
But how do you know if P2y prime and P2x prime are going to be positive?
Because of the picture. Oh, you mean this? The answers? Because however it works out, tells you,
Oh, okay.
right? So that's why this step is so important, because if you didn't put this in as -6, then you're not getting the right P2y prime. If this negative was large enough to overwhelm this positive, then it's possible that that could be a negative number, right? And so if we do this subtracted, -12, and then this still ends up positive, right? But you can imagine that if this was small enough, or large enough, when I subtract it to the other side, the other ball actually has to be going down in order to make it work out. Good. Trust the math, but make sure you put the signs in. Huh? I honestly don't know.
Because
I hope not, because I felt Sophie's hernia.
Because I've been like, I think I have a hernia.
I felt her hernia.
No, you don't.
I think she does. That's
No, you
what she's laughing.
P2y prime. Guess what?
And I just lifted up my shirt and placed it on my stomach.
All right, let's not. I hope they didn't see
P2y prime, what'd you get?
Don't
9.5.
post it.
9.5?
Kilogram meters per second. Good. Positive?
Yes, I got 9.5.
Positive.
Yes, positive.
All right, so this one is 9.5 kilogram meters per second.
Great.
Oh, I just wrote the unit as P2y prime.
And then you make another time.
All right, so then I'm going to erase all this.
Now we can just do a squared plus b squared equals c squared.
Right, so now let's redraw, because this represents the total momentum of ball number 2. It's moving up at 9.5 and moving to the right at 22.3. Makes sense? So up at 9.5, to the right at 22.3. This one is 22.3. This one is 9.5.
Now, which way does the line that way?
The final answer should always make sense to the vectors that you just drew, up and to the right. From the start to the finish is the proper way of saying vector addition, from the start to the finish. But another way is to say the arrow should point up and to the right. So up and to the right
At that angle?
No.
is P2 prime.
What if it's up and to the left? Wait, if I drew my triangle the other way, like with the 22.3 on the ground.
So if I do it with the vector on the ground,
Right, and up.
to the right and up, still points up and to the right. If you did not draw that, then your vector is wrong.
So fun.
The proper direction of P2 prime is going to be this vector, or this angle, theta, because that's offset from 0 in the proper direction, which is the same as saying this angle up here not this angle down here, because this is offset from the 90. That is not the proper direction of P2. P2 prime.
So we're solving for the theta.
We're solving for P2 prime and theta, because P2 prime is a vector on that direction. So I'm going to do a squared b squared c squared. So P2 prime is the square root, 22.3 squared plus 9.5 squared, which is what?
24.2.
24.2 kilogram meters per second. And then I'm going to find theta. Now I know all sides of the triangle, so I can pick any trig function that I want. Right? But I like tangent. So the inverse tangent of the opposite, which happens to be the purple, is 9.5, divided by the adjacent. Theta adjacent is the orange, 22.3. Theta is the inverse tangent of those things. And so theta is what? 23 degrees.
Oh, so you like say, P2 prime is.
This is theta.
Wait, then we
Opposites
have
over
to
here.
undo it to get freaking B2 prime.
Right? So my final answer is P2
That's not the
prime
final answer.
equals, very good, it's not the final answer,
It's not.
is 24.2 kilogram meters per second at 23 degrees.
But that's
What
not.
was the original question?
B2.
B2 prime. How do we find B2 prime based on P2
Divide
prime?
24.2 divided by whatever its mass is.
Right, we are not done until we divide by the mass, because the question wasn't what is the momentum, the question is what is the velocity,
So we have to divide
By the mass.
right? So we're gonna say, we're up here maybe,
2.31.
P is mv, P2 equals m2 times v2, and we're looking for the prime condition. And we know that P2 prime is 24.2, and we know that m2 is what?
2.31.
2.31, B2 prime is what I'm trying to find.
Divided by 2.31.
What did you get, Sally?
P2 prime is what, Georgia?
What is 24.2 divided by that?
10.5.
10.5 meters per second.
Times.
The magnitude is 10.5. The answer as a vector is 10.5 meters per second at 23 degrees.
Who was able to solve that on one piece of paper?
I did.
My writing system. Jeez, I used like 4.
I would prefer that you needed more paper, because you drew a nice big picture
Yep.
and you kept track of all the triangles.
Yes, sir.
I
Right?
did.
Absolutely.
You write your name in like 4 lines.
Lane. On an assessment, what we just did there is at least a 10 to 15 point problem.
But it took me 45 minutes to do it.
Because what it really is 2.5 problems together, right? It's the conservation of momentum in the x direction, it's the conservation of momentum in the y direction, and then it's the knowledge that the answer is not the momentum. The answer is the velocity, so that last step is what gets you that extra half a bit there.
I'm so sorry. This is so long.
Andy?
Yeah, I forgot the data.
That on my hurry. When you find like the sides of the triangle, that it would be correct, because if you mess it up, you get the whole thing off. Might just be my app.
To check the sides of the triangle. The key there is just making sure you're lining up your opposites and your adjacents, right? And whatever you get, just show your work and go with it, because the only thing that could possibly happen is that you flipped them and you made x, y, and y, x. As long as you do the rest of it with that assumption, then that's really only 1 point off, because you only made one mistake. Right? Does that make sense? Just be as organized as I was. separating out the two directions, and you'll be fine.
Is this gonna be on the quiz?
Lois, yes.
What are we
This problem?
Phi is the angle. Rather.
The Greek letter used to represent the angle is arbitrary. Theta, phi, alpha, beta.
Well, what about when you do like the theta minus 180?
So the only reason why I did that, suppose that,
Suppose that it was like.
suppose that this hit it so that when P2 prime happened, ball number 2 actually ends up going this way, right? Then when I find what we would call theta, I cannot assign that as the direction because theta is less than 90 degrees. So then I used phi to represent a new angle
Lord.
that's based on the proper compass.
Okay, you just.
But the actual like letter doesn't matter. But does that make sense? Right? It's a question of which quadrant is it in.
It's like the LeBron, no.
Yeah, it was
Like in the LeBron problem, like the velocity at like.
Yes, exactly. Yes, exactly like the LeBron jumping from the baseline question.
Wait, what do you mean?
Well, so if it's pointed this way, then phi is that. But if it's pointed this way, then phi is only from here to there. Right? But theta is the angle inside of the triangle. But phi is always measured from 0 degrees around counterclockwise. So what I'm saying is that if it's in the first quadrant, theta is between 0 and 90. If it's in the second quadrant, it's between 90 and 180. If it's in the third quadrant, it's between 180 and 270. Right? And so your final answer should make sense. If the final answer says that this is at 23 degrees, then that tells me that ball number 2 is going up like this. And if your picture doesn't show an arrow going up like this, then that's wrong. Charlotte?
Suppose P2 prime was at 0 degrees, would we have to write at 0 degrees?
Yes, because of the fact that there was 2 dimensions to begin with. If you just put positive, how do I know you're not talking up?
Right.
And so yes, put 0 degrees. Put 90 degrees if it goes straight up, and so on. Good. Andy?
What if it was at negative 30, 23?
Yeah,
Would it be negative?
you can do that, but I don't like it.
I've never heard of it.
If you want, you can totally assume that going this way is positive 360 degrees and going this way is negative 360 degrees.
No.
AP, in the AP physics, the readers do accept negative angles like that. You can totally do that, but I don't like it because it feels confusing and it also feels like you're going to forget the negative and then get it wrong. So I tend to tell you to just stick to doing the positive quadrant analysis like that. Anybody else? All right. That's it.
Wow.
That's over.
Great.
Have a great 3-day weekend.
Study that.